A celestial body on the run. NASA has recently tracked down a mysterious entity that is hurtling through space at a breakneck speed of 1.6 million kilometers per hour. As a result, the object is moving so fast that it could escape the gravity of the Milky Way and shoot into intergalactic space. But what kind of galactic Speedy Gonzales is this in detail? How is it possible for a celestial body to reach such an insane speed, and how was it discovered in the first place? Have you ever heard of NASA's Backyard Worlds project? On the one hand, this research project is searching for unknown brown dwarfs and stars close to the sun in the backyard of the solar system. And on the other, it's on the lookout for the hypothetical Planet 9, which is said to be hidden deep in the Kuiper Belt. But what kind of academic career do you actually need to have in order to take part in this exciting galactic hunt? Well, none at all. Backyard Worlds is a citizen science project funded by NASA, but mainly run by volunteers. However, they don't have to have any prior knowledge of astronomy, but only have to prove that they have taken part in a tutorial. And a look at the exciting objects that have already been added to the star charts thanks to Backyard Worlds shows that the discoveries made by amateurs in no way have to hide behind those of professionals. Made available to the public in February 2017, it took just 4 months for the community search to land its first direct hit in the form of a brown dwarf 111 light-years away. A brief introduction. Brown dwarfs are celestial bodies that occupy a special position between stars and planets. As the objects have less than 75 Jupiter masses, they are not able to stimulate hydrogen fusion in their interior. But because they are also more massive than gas giants, they are still heavy enough for deuterium fusion to begin. And we now know that brown dwarfs are anything but rare in space. Backyard Worlds participants have now been able to track down over 4,000 of these celestial bodies. But what's more, a resourceful amateur astronomer also discovered the oldest and coldest known white dwarf with a dust disk. But now the members of Backyard Worlds have made a much more rapid discovery, in the truest sense of the word. As NASA announced in August this year, we now know of the existence of an object in the Milky Way that is traveling at an incredible speed of 1.6 million kilometers per hour. But what leads to this insane speed, and how do you even track down such a fast celestial body? A breathtaking find. The foundation stone of the cosmic blitzer photo was laid with the NASA mission Wide Field Infrared Survey Explorer, or WISE for short. As part of this mission, the eponymous space telescope examined the sky in the mid-infrared range from 2010. The mission was reactivated in 2013 under the name NEO-WISE and discontinued on August 8, 2024. Some time ago, the WISE images finally came to the attention of longtime Backyard Worlds participants Martin Kabatnik, Thomas P. Bickel, and Dan Castledon. The amateur astronomers had become aware of a faint, fast-moving object with the scientific designation CWISE J1249. Kabatnik, who incidentally lives in Nuremberg, could hardly believe what was moving across his screen on the WISE images, and NASA quotes him as follows. I can't describe the excitement. When I first saw how fast it was moving, I was convinced that it must have already been reported. But as we now know, this was not the case. And after the clues from the Backyard Worlds community were received by NASA, follow-up observations with several ground-based telescopes were to confirm the exciting discovery. And so it was that the citizen scientists ultimately became co-authors of an official research study published in the astrophysical journal Letters. As already mentioned, the cosmic rabbit's foot, with its astonishing speed, is currently also taking flight from our local Milky Way. But the bottom line is that it is by no means just the high speed that makes CWISE J1249 so extraordinary. There is also its mass, which is so small that classifying it as a celestial body is complicated, to say the least. And in the absence of reliable facts, researchers must therefore delve into the world of theories. It is therefore conceivable that we are dealing with a low-mass star here. Provided it is not constantly fusing hydrogen in its core, it could also be classified as a brown dwarf. However, if this is indeed the case, the celestial body would become an astronomical exception. This is because we know of no other brown dwarf that is about to turn its back on its home galaxy. And while the object is certainly not getting into the iron on its journey through space, data collected with the Keck Observatory has revealed that it actually contains much less iron and other metals than would normally be expected for stars and brown dwarfs. According to NASA, this unique composition suggests that the celestial body is exceptionally old and could even belong to one of the first generations of stars in the Milky Way. Why is the object so fast? Well, unsurprisingly, the experts can only speculate. One hypothesis is based on the assumption that CY's J1249 once formed a binary star system together with a white dwarf. At some point, however, the white dwarf could have extracted so much material from its companion that it exploded as a supernova, literally hurling its stellar companion away from it. An alternative theory suggests that the later Speedy Gonzales was originally at home in a closely connected star cluster, a so-called globular cluster. Ultimately, the chance encounter with several black holes could have caused the object to make an unexpectedly rapid descent into the depths of space. In this scenario, it's indeed possible that the complex dynamics of this three-body interaction could catapult a star out of the globular cluster. The bottom line is that it is now up to the experts to find out which of the two possibilities is the more likely. In order to decipher this, the scientists will soon take a closer look at the nature of CY's J1249 and will hopefully soon be able to say with absolute certainty what turned the mysterious object into a cosmic lead foot. The fastest star in the Milky Way. In view of the speed just presented, the question arises as to whether it can go any faster. And the answer is yes, and significantly so. Because although CY's J1249 travels a good 444 kilometers per second, it is no more than a lame snail compared to the star's S4711. Unbelievable but true. The speeding star in the center of the Milky Way moves at a monkey speed of 24,000 kilometers per second, or 86.4 million kilometers per hour. This corresponds to up to 8% of the speed of light, and the fact that the celestial body can reach this speed is again due to its special position. As the fastest known star in the Milky Way, S4711 orbits our central black hole Sagittarius A star, and the stellar speed miracle takes just 7.6 years to completely orbit the mass monster. In detail, the discovery of S4711 can be traced back to the research team led by Florian Peisker from the University of Cologne. They had combed through the observation data of two spectrographs at the Very Large Telescope of the European Southern Observatory, ESO, and traced the orbit and speed of several faint stars. The experts had previously identified S2, an unusually bright star in the vicinity of our central black hole. And while S2 was subsequently used to put Einstein's predictions on the gravitational redshift and the so-called Schwarzschild precession to the test, it also became the fastest known star in our home galaxy. But while S2 still takes 15.6 years to complete an orbit, S4711 accomplishes this feat more than twice as fast. However, the new record holder does not maintain a consistently high speed. Its average orbital speed is around 0.5% of the speed of light, but it only reaches its maximum speed of almost 8% in the immediate vicinity of the black hole. And experts actually assume that we could be dealing with a so-called squeezar here. In other words, a class of star that so far only exists in theory. On paper, squeezars orbit their supermassive black holes in extremely eccentric orbits, so that they are strongly heated by the tidal forces of the black holes as they approach, before they cool down again in the distance. And indeed, spectral investigations have shown that the thermometer on S4711 climbs to a good 10,000 Kelvin or 9,700 degrees Celsius. For comparison, the surface temperature of the Sun is around 5,772 Kelvin or 5,500 degrees Celsius. However, the researchers also assume that the strong tidal forces also cause extreme bursts of radiation in such stars. And if S4711 is confirmed as a squeezar in the course of further observations, it would be the first known object to bring this hypothetical class of stars from theory to reality. At the same time, The discovery of S4711 and 4 other faint stars in the center of the Milky Way also indicates that a whole population of previously undiscovered stars could still be dormant in the extreme zone around the black hole. And together with the stars already detected in the so-called S-cluster, the orbits of the new discoveries form 2 disks that are almost edge-to-edge at a 45-degree angle to the main plane of the Milky Way. What this unusual arrangement is all about, however, is just as unclear as the question of how stars can even form in the vicinity of a black hole without being torn apart by its gravitational effect during their formation. However, as young protostars with dust cocoons have already been found in the vicinity of Sagittarius A star, scientists believe it is possible that a second, much smaller black hole lies dormant in the heart of the Milky Way. This would counteract the gravitational grip of its more massive counterpart and thus save the stellar burst clouds from annihilation. And we'd love to save you from ever missing another video from us. So press the thumbs up and subscribe now to stay up to date from now on. We'll see you soon.